In our last session, we saw what algebraic expressions are. Friends, in this session, we will learn about addition and subtraction of algebraic expressions. Let's start. Our friend Raj had 5 pencils and 3 books. His father gave him 3 pencils and 2 books as gifts. How many pencils and books does Raj have now? Raj will now have 8 pencils and 5 books. How did we reach this conclusion? We added the pencils gifted by his father to the pencils he already had. Similarly, we added the books gifted by his father to the books he already had. So, we can see that we have added the existing pencils to the new ones and also the existing books to the new books. Now suppose Raj's sister comes and snatches 4 pencils and 2 books from him. Can you tell me how many pencils and books are left with Raj now? Absolutely correct. 4 pencils and 3 books. Adding and subtracting algebraic expressions is also based on a similar logic. Let's check how. In our last session, we understood what like and unlike terms are. Look at these terms. We know that 2 terms are like if their algebraic factors are the same. 2 terms are unlike if their algebraic factors are different. Just like we added pencils to pencils and books to books, similarly, we can only add 2 like terms to each other. We never associate pencils with books. In the same way, we cannot add 2 unlike terms to each other. The same is the case with subtraction. Only like terms can be subtracted from each other. We cannot subtract 2 unlike terms. Let's see an example to understand this concept better. Look at these expressions. Let's add these 2 expressions. We get this after opening the brackets. We know that only like terms can be added and subtracted. That is why we group like terms. Now, when we add the pairs of these 2 like terms, we get the result. We have learned another simple way to add 2 expressions, which is to place the expressions in vertical order. When we add the expressions in a vertical order, each expression is written in a separate line, in such a way that the like terms are stacked in a column one under the other. And now we will add according to the columns. First, we will add the terms of this column. Since in our second expression there is no term with a factor, there is no term below 6a. So, we will write this 6a this way. This is our last answer, which is exactly like this. In this session, we looked at the concepts behind adding and subtracting algebraic expressions. In the next session, we will understand it better with some examples. In our last session, we saw the concepts of addition and subtraction of algebraic expressions. We also saw, with the help of examples, how we add 2 algebraic expressions. Friends, in this session, we will see some more examples of addition and subtraction of 2 algebraic expressions. Look at these 2 expressions. Now let's subtract the second expression from the first expression. We should always keep in mind that at least the second expression should be written inside the brackets. This is because we have read that when we subtract one or more terms from an expression, the signs of all the terms change. Thus, upon opening the brackets, we get thus positive x becomes negative x and negative 3 becomes positive 3. Now, we group all the like terms. After adding the like terms, we get the final expression as. Now look at this step. We can also write it as. Now if we compare this part with this part, then we can see that the signs of x and negative 3 are inverted. So, we can say that subtracting a term is like adding to its additive inverse. So, subtracting x means adding negative x and subtracting negative 3 means adding positive 3. This leads us to a simpler way of doing the subtraction. We can subtract these two expressions by placing them one below the other. When we do subtraction in this way, every expression is written in a different line in such a way that the like terms are one below the other in the same column. Notice that we have changed the sign of all the terms of the second expression because we just saw that subtracting a term is like adding its inverse. Now look at this example. Let's solve it. Here, we first have to find the sum of these two expressions and then subtract this expression from that sum. So let's add these two expressions. Let's first write the first expression. Now while writing the expression which is to be added, we should note that we write the like terms one below the other. Thus, we get the sum of the first two expressions. Now, we have to subtract the third expression from this sum. So let's write this expression first. Now once again, while writing the third term, we should write the like terms one after the other just like this. Now, we will change the sign of all the terms of the second expression. This is the result we get after adding. So in this session, we learned to add and subtract algebraic expressions using examples. In the next session, we will look at some common misconceptions related to addition and subtraction of algebraic expressions. In the previous session, we saw how to add and subtract algebraic expressions. Friends, in this session, we will look at some common misconceptions related to this concept. Look at this question. Can you tell us what is the right option? The correct option here is B. Now, for some of you, the answer may have been either option A or option C. Let's see why. We have read about the commutative property in the previous classes. Always remember that commutative property is true for addition. For example, 2 plus 4 and 4 plus 2 are the same. But subtraction does not show commutative property. For example, 2 minus 4 is similar to negative 2, but 4 minus 2 is similar to positive 2. This means that 2 minus 4 and 4 minus 2 are not the same. Commutative property is not true for subtraction. Let us now use it here in the given question. Our question says that 5x squared plus 3 be subtracted from 3x plus 4. The expression from which the second expression is subtracted will be written first, and then the expression that is to be subtracted will be written. So, our first stage will look like this. After simplifying the expression of option A, we will get this result. After simplifying the expression of option B, we get this result. We can see that the two expressions are different. Then, option C cannot be the right answer. Hence, option B is the correct answer and not option A or option C. Now let us look at the other misconception. Suppose I asked you this question. I give you two options. Which is the correct option? The correct option is B. Let's see why. This is the expression that will be subtracted. So, our first step would look like this. In our last session, we have seen that when opening brackets while subtracting, the signs of all the terms inside the brackets get inverted. Now this is where we make mistakes. When opening the brackets, we replace 4x with negative 4x, but we forget to replace the symbol negative 5. We write negative 5 in the same way, so our second step would look like this. After simplifying in this way, we get this answer. We have to pay attention that the sign of all the terms of the expression that are subtracted will change. So this would be the correct step. After simplifying, we get this result. Thus, option B is correct. In this session, we saw two misconceptions related to subtraction of algebraic expressions. In the next session, we will learn to multiply algebraic expressions.